Hi, this is Mr. Max. So I am doing some questions on integration, and I'll be doing two of the same or similar questions. So this one was in the paper of last year here in Namibia. Obviously, it's at advanced subsidiary level, and again, as I said, it was question five in that exam. So if you have access to the question paper, you can always check it out there. Right. I thought I would just do it separately. So we continue with our series this week that I'll be doing all questions on integration, and I'll be doing this until the end of this week. I'll just be doing my series on integration and further integration as well. So this is also one of those questions on further integration. And then during the next week, I'll be doing numerical solutions to equations. Right, the polynomial f of x is defined by f of x is equal to 4x cubed plus 16x squared plus 9x minus 15. And here you're supposed to find the quotient when p of x is divided by 2x minus 1. Okay, and show that the remainder is minus 6. They are saying P of X. So you should be very careful when you do synthetic division. I will suggest that you do long division because of this 2x that is over here. But I'll do both for you to see what is it that you need to do when you apply synthetic division. And then obviously the questions, they follow each other. Then here you have to find the integral of f of x, all of that, upon 2x minus 1. As you can see, the 2x minus 1 being the divisor here, okay, with regard to dx, or with respect to dx. I'm also going to explain a few questions on how to integrate these type of expressions before I then finish that one. And then there's a C part that is attached to it. Factorize f of x plus 6. You add 6 more to this. The remainder is minus 6. So whenever you're adding, the opposite of that remainder, okay, the additive inverse of that remainder, it means now that this 2x minus 1 will become a factor. It will factorize within that new polynomial without, leaving a remainder. And so would be whatever your answer is in part A. So you will do that, you find different values, and then you have f of cosec 2 theta plus 6, which is basically now an angle that we throw in there with a given domain. And you'll see that, remember, cosec is the inverse of sine, so 1 over sine, and then we'll continue. All right, so I'm starting off with the first one, the polynomial. Now remember I said I'm going to do long division and I'm going to do synthetic division. Okay, so let's start off by perhaps doing that long division. I hope my line is long enough. Right. So this is 2x minus 1. Over here we have got 4x cubed plus 16x squared plus 9x minus 15. You like to do some side work, okay, or rough work, so you can just see how one does it. So you start with the 4x cubed. We'll divide it with the 2x, and whatever that answer would be, 2x into that will be 2x squared, and that is what comes up over here. Then you multiply 2x times that, that gives you 4x cubed. You multiply with negative 1, that gives you negative 2x squared. Okay, very important that you remember that. Extend the line a little bit, so obviously I'm going to put brackets here because I'm going to be subtracting. Now when I do subtract, I will be end up with, this is obviously going to be 0. So I have 16 double negatives makes it a positive. So this is 18x squared. So before I do my division again, I'm just going to bring this down. Okay, so then we take the 18x now, the 18x squared, this one. All right, we're going to divide it with the 2x again. So we're going to divide it with the 2x. And that is going to be 9x as an answer. So positive 9x over here. I could have started moving that 2x squared aside, but it doesn't really matter at this stage. So we're going to go back 9x times 2x, that is, well, that is 18x squared, and 9x times negative 1, that's minus 9x. Again, you're going to draw your line, and I just extend it a bit because I have to bring that minus 15 down, and obviously I'm going to put brackets here and do the subtraction. hopefully you're following. Now, when you do that, you will be left with um, double negatives. That makes this an 18x. And I'm going to bring down all of that. That is going to be minus 15. Okay, so I'm going to go back to my side work and I'm going to divide this 18x by my 2x. And then if I do that, okay, if I do that, the x's cancel and I have positive 9. So positive 9 comes over here. So 9 times that, of course, that's going to give you the 18x. And if you say 9 times that is negative 9. And then obviously when you now bring in your brackets again, okay, you will see that if you do everything, you're going to get a remainder. So that's going to be 0. And the remainder here will obviously negative 15 plus 9, which is negative 6. Okay, so that is what we have. So I'm just going to write down the quotient, 2x squared plus 9x plus 9. So it is 2x squared plus 9x plus 9 minus 6 upon our remainder, which happens, our divisor, which is it 2x minus 1? Let's just go make sure. Or is it 2x minus 1? Yeah, 2x minus 1. All right. I'm just going to write it in this form because that's what we're going to require us to do whenever we write it in the integral form. Okay, so you can, with the question, if you read the question, it says that you should show the remainder is negative 6. Now you can use the factor theorem in order for you to show that the remainder is negative 6, and then you can get a mark by that, but then don't just end there. So I'll suggest that you obviously also do this. Right, so let's see. Let us take, okay, and let us divide then using synthetic division. I know that if you are doing ordinary level, you're told that if this x, your coefficient is other than 1, then you should not try that. There's a good reason why we say that, okay? Because there's that extra step that you have to show when you do it using that fraction. So we're going to divide this using synthetic division, okay? So I'm just going to also take my 2x minus 1. And in fact, if you were to take your 2x minus 1, and if you were to say 2x minus 1, if you let it equal to 0, this will give you that x is equal to a half. Right, so you're going to obviously start off, maybe you can draw yourselves a line like so, and a line like so. Okay, and then I'm going to put my a half over here. And these coefficients of that I have here, this constants, I'm going to write them. I'm going to write them over here, so that is going to be 4, that's going to be 16, that's going to be 9, and that's going to be negative 15. So first thing we do, we bring this one down. Okay, that's the first thing you do. Oh my goodness, that is 4. And remember, we are going to multiply a half of 4. Okay, a half of 4. In fact, I don't have to. Half of 4 is just 2. And then once we are going this direction, let me just save because I've seen something very awkward there. I'm just going to save the document every time. So we are going to add. So we are going to add going in this way. We're going to add. All right. We're going to add. My goodness. So we're going to add. So adding this will give me 18. Okay. Multiplying again, half of 18 is 9. Adding this gives me another 18. Multiplying again, half of that is 9. Right, so my remainder here is negative 6, or you can see the negative 6 over there. Now, what you need to do is you need to take that answer, okay? You need to take that answer because you have this 2 over here. You need to take that answer 4x squared plus 18x plus 18. You need to take that answer and you need to divide it always by this number. That's something that you should always remember for you to get that p of x. Okay, so this implies that we have the answer of 2x squared plus 9x plus 9, obviously leaving you with the remainder of negative 6. Now it's very possible that if you were to go this method that you might not do that and then you have a problem, and And that is why the long division was quite straightforward, because it brings you directly to that number, because this cannot be the answer over here. Can you see that? Okay, right, because you have that, so you need to divide that by 2, I mean. Okay, because that is twice that, so you need to divide the final answer by 2 in order for you to get that polynomial. Right, so that is what we have over there. Now I have essentially I am just deviating a little bit, because if you look at question 2 of the same, of question 2, we now have to integrate. Can you see that? And because we have to integrate, I just want to show you how is it that we're going to integrate that. So if you look at this function, okay, let me just grab it. If you have to look at how that integral is, right, and I'm going to write it over here, you can clearly see that, of course, from our answer that we have over here, which I can also grab. Okay, it's very important. So this answer, I'm just going to bring it. Right, there is clearly something that we need to do. Now, remember, I wrote the remainder upon that the other way. So basically, what it means, you will have to do the integral of f of x, which is what this has become. Okay, because you follow that we have our f of x. Well, okay, all the way over there. Just want to make sure that we are on the right path. Okay, and then we're going to divide that. So that's going to be that 2x plus 9, that was supposed to be p of x. All right, so that's basically this 2x square plus 9x plus 9 minus 6 over, because that's the remainder, 2x minus 1. And we've got more than one term here, so we're going to put this in bracket with respect to x. Now, you might be able to integrate 2x squared plus 9x plus 9. But what about this 6 over 2x? And that is where this comes in handy, that I'm showing you, all right, how to integrate, the natural log, or 1 over x giving you the natural log, and stuff like that. Okay, now let's just take a few examples. All right, before I come to that. So let's just take a few examples. I'm just going to leave this and I'm going to come back to it, and I'm going to do that. So I'm going to do the examples over here. Oh, okay, actually I see I have it over here. So I can actually start with my examples right here. So I'm going to draw a line. Okay, now we don't give you this formula, so you need to know this formula. Right, so let's let's go back to our work, and hopefully you remember our work on what is it, on differentiation, because differentiation, opposite of that, anti-differentiation, is integration. So from differentiation, if you were asked to differentiate y equals the natural log of x, then you know that dy dx was nothing but 1 over x. Okay, also, if you were to differentiate something like y is equal to, let's say, 3 times the natural log of x, when you are differentiating that, you know that this can be written as dy dx is equal to 3, and then you take the derivative of of the natural log of x, which is 1 over x, and simply this becomes 3 over x. Okay, so this one tells me that if I have a constant and I put the constant a over here, right, then the derivative of that constant will just be something like, so if I have the natural log, or let's say if I have y equals to a times the natural log of x, then its derivative let's say, just clean this one so you can just be nice and just write it nicely. Okay, if you have a function and you have to differentiate the function d by dx of a times the natural log of x, I'm going to put them in the bars here, okay, when you differentiate that, you are going to get nothing but a times 1 over x. That's the derivative of that. So that a times that derivative of the natural log. So essentially, this is differentiation. So we need to be able to know, okay, if I do that for differentiation, then I can actually go back, right? So since differentiation is the opposite, so if I was to integrate, something like, let me just draw a line over here, just to create space. So if I was to integrate, let's say, anything a over x with respect to x, then its integral, okay, must be this. You are going back because integration is the opposite, is the reverse, is the antiderivative. So what is the derivative? We have got a, the natural log of x plus the constant of integration. Does that make sense? So let me give you a few examples. So let's take example 1 just to emphasize on that point. All right, I'm going to extend I'm going to extend it a bit further. So let's take something like integrate. Let's say integrate 3 over 5x with respect to x. Okay. Now we can grab out that 3 over 5, put it in front of the integral because it's a constant. And then we have got 1 over x here with respect to x. And what is the integration, or what is the integral of 1 over x? Going back to differentiation, so we have 1 over x, 1 over x, that is the natural log of x. So it's going to be that constant, which is 3 over 5, times the natural log. I'm going to put it in this modulus brackets or this bars because that value there cannot be negative, all right? And then obviously plus the constant of integration. That is how you do it, without having too much of a problem. Maybe I can do one more example. What if sometimes you have, very simple one. We could take something like maybe example 2. So what if you have to integrate, you can say anything 7 over x with respect to x. Of course, you can grab at that 7 because it's a constant, and then you have 1 over x with respect to x. And it is 7 times what is the, if you differentiate, if you integrate that, that's going to be the natural log of x, right, plus the constant of integration. Now, I want to extend this law that I have given you, and I want to extend it how to integrate, let's say, these types over here. So let's just change the color. I'll probably have to bring in a little bit more stuff like that. How would you integrate something like this? So we can call this example 3. Integrate 5 all over. Then we have 3x minus 2 with respect to x, and that is how it is appearing, when we are going to do this. Can you see that? If you have to go back to our problem, let me just scroll back to the correct place. Yeah, here that I wrote. So this part that I'm talking about. How do you integrate that part? Okay, now we're going to extend the law. So let's just say, if you were to take out the constant, that 5 is a constant, so you take out the 5, and then you are left with the integral of 1 all over, that is 3x minus 2 with respect to x. Now, I want to see something quickly because from our work on differentiation, if you have, let's say, I'm going to write this answer over here, but I just want to explain that concept. Okay, so I'm just going to go down. So let's take that 3x minus 2, and let's say you are now asked to integrate. So let's say not integrate, but let's say you're supposed to differentiate y equals to the natural log of 3x minus 2. How are you going to go about this? Now, this is a composite function. It's not just natural log of x, not one variable. There's 3x minus 2. There's stuff in there. So we were normally using the chain rule, and you can decide, it's totally up to you what this one is. Maybe we can say that is u. Now, the chain rule is dy dx is equal to dy over that something. I've used u, some people can use t, times that same something over dx. Okay, like dy dx are going down like this. So here we have du. So at this moment, I have something like this: y equals to the natural log of u, and I also have that u is equal to 3x minus 2. Now let's take let's differentiate it. So this one over here, dy du, remember the natural log of is nothing but 1 over u. Okay, if you were to differentiate that, and du dx is nothing but 3. That is the derivative of 3x minus 2. Derivative of 3x is just 3, and the constant is 0. Now, what does the chain rule imply? It implies that we have to multiply these things together. Okay, so we are going to multiply. So using this, we are going to say dy du, which is 1 over u. We're going to multiply it by 3. At the end of the day, we have got 3 over u, but what was my u again? My u is this value here, so I'm going to have to replace it, so that's 3 over 3x minus 2. So that's what we do whenever we have the chain rule. So I'm here and I need to go back. So you see that if I'm here, if I go back, I will have the natural log of, so if I was to integrate, let me just write it here. So if I was to integrate, so therefore if I was to integrate something like this, which is 3 over, okay, that's 3 over 3x minus 2 with respect to x, it should equal to, let's go back all the way, what was it? The natural log of, there we go, the natural log of, it should equal to the natural log of, then now remember, there's the natural log of 3x minus 2 plus the constant of integration. Okay, now there is a little bit of a problem when we have something like that. Um, and that comes from the value then, because I'm not completely done. So say for example, I was to put a value over here. So let's say I was to put, we can actually keep that as red. So say for example, I can pull out that 3 like the way I did that. So that 5 will just multiply out with that. So if you have the law, because the law has an extension to it, okay, and what happens whenever you have um, here, whenever I add a number, like say the number here is a, and I ask you to differentiate that. Now of course that a is just a constant multiplier, it will come here. Can you see that? And obviously once you have that derivative, it's going to be that a, which is like a over u, right? And when you multiply the two things together, that constant will just come across it. All right, so um, to differentiate now this part, like where I'm here, right? So how will you do this? So this is nothing but 5, and 1 over that is going to be the natural log. But there's something that I'm going to show you, is the natural log of 3x minus 2 plus c. Now there is something there that we are going to do, because you see this 3 that we have over here, right? It came on top over here when we did when we did that, because I have a 3 here, so it's supposed to be 1 over. Can you see that? And because I have a 3 here, to go back, I will have to divide by 3. So I'll be dividing by that 3. By whatever that derivative is, I will be dividing. So I'm going to divide that by 1 over 3, or I'm going to multiply by 1 over 3. This is essentially where this value of a is. So at the end of the day, this is 5 over 3 natural log of 3x minus 2 plus c. So that will be the same concept that I'll be applying at this one that I have done towards at the end here. Okay, so that 1 over 3 that is there, so I'll have to sort of multiply out that 1 over 3. So the rule is I just want to add a page, append a page. So the rule is, if you were to integrate, something like 1 over ax plus b with respect to x, then you will be multiplying out that 1 over a, because that 1 over a will definitely come out, and then you're going to multiply that by the natural log of this 1 over the same stuff, the natural log of, in bracket, ax plus b. Then you say plus the constant of integration. So that is the rule that we are going to apply throughout as we work with that. Right. Because you were having the a on top, so now you have to have the a under. That's like the reverse. So at the end of the day, that is what I'm going to apply, and I've shared those rules with you. If there's a constant, how do you get it, and stuff like that. This is something that you're supposed to know, and with more practice, you can actually become perfect. So let's look at that B, because I was not done with the question. Now I hope you still remember the question. So B, our f of x, okay, our f of x was, we have to find our f of x now. If I have to go back to what our f of x was, just to remember, I think I've written it somewhere down. Okay, actually can't find it. Let me just go look for what was our f of x. Okay, it's over here. So this is the part that I want to do. So let's just grab this and take a snapshot. So this is the part that I want to do. Okay, we are now going to integrate that. Okay, we're going to integrate that to finish the question. All right, so let's just clear this up, and then we paste. Right, this is now what we are going to integrate. Good, that we are supposed to integrate. Yeah, I have to continuously save before this thing gives me problems, because I can already feel it that it's about to give me a problem. Right. So if you were to integrate this, now we know that the integral of this, you just add 1 to the power, so that's 2x cubed over 3 divided by that same power, plus add 1 to that power of 1, which is 2 divided by the same power. This is going to be 9x, okay, and divide that by 1. All right, now minus, I'm going to take out the 6, okay, then remember we are going to multiply this from using my rules that I have. We're going to multiply this by 1 over 2, that's the 1 over 8, okay, and this is obviously, let's see if I have space here. So I'm just going to write it underneath here. So that's the natural log, it's the stuff that needs to fit in there, of 2x minus 1. All of this, obviously, I'm going to add the constant. Right, so let me just clean it up nicely. So it's 2x cubed over 3 plus 9x squared over 2 plus 9x minus half of 6 is 3, the natural log of 2x minus 1 plus the constant of integration. That is how that particular question B, that is how you're supposed to do that. All right, so I just thought I must explain all that stuff there before, as you're busy with integration, you might not really know how to integrate something like that. But f of x, you have to use that, okay, because it's that over 2x minus 1, and then 2x minus 1 go into f of x, giving you that, okay? So you need to integrate that. Okay, we have now a scenario where we are told that we are supposed to factorize f of x plus 6 completely. So I'm going to do it in those steps, okay? We're going to do it in the steps. And what I want you to take note of here, obviously, is that if you look at f of x, the way it was given, f of x originally was given to us as 4x cubed plus 16x squared plus 19x minus 15, and it had a remainder of minus 6. So if I'm going to add that remainder, okay, if I'm going to add that remainder, then I'm going to have that f of x is 4x cubed plus 16x squared, and then you have 9x plus 9x, and then you have negative 9. Negative 9. And now, because of this, it implies that f of that 2x minus 1 is a factor, all right? It's not going to be a factor of all of this. And you can check it, right? You can check it. We can do the division. You can see that we are going to get the answer, right? If you were to divide 2x minus 1 into that, you're going to get a complete factor, okay? And we already know what it is because we have already calculated. We know that 2x minus 1 now is a factor. And from our long division before, we had 2x squared plus 9x plus 9. Okay, I can say that is equal to 0 because this is now a factor. Can you see that? So so there's not going to be a remainder left. Can you see? Now let's just factorize those ones because they say we have to factorize completely. So if you factorize 2x minus 1, and this obviously you can divide that into that, but this is also something that factorizes, and you can see that it's going to be 2x plus 3 and x plus 3 if you were to factorize this part. That equals to 0. So we have factorized completely. Okay, we have factorized completely as the question was demanding, but we are not done. It says factorize completely, and then now we must solve this equation. So we are going to take this equation as it is. It's a trig equation, and they want us to solve. There we go. There we go. My goodness. Let's hope it's going to restore. I didn't want this video to be so long, but it's because of the other work that I was doing in between. I hope it would have restored everything. It doesn't appear like it have done that. Okay, it haven't appeared like they have done that. Let me just see something quickly because these things are two. Let's open this one. Let's see if it's going to do all of that. Ah, I got the correct one now. I got the correct one. I hope so. Okay, but now you can see, you know, our answer from before is gone. Our answer from before is gone. There is another one that I've seen. I have that. That's the one. That is the one. Yeah. Okay. All right. So, well, hope you follow with me because you have a little bit of a malfunction. So, I'm just gonna write down what those factors were. I remember those factors were we had 2x minus 1, we had 2x plus 3, and then we had x plus 3, and we say that equals to 0. That is the factorizing that part completely. And once you have something like cosec of theta, that is the same as 1 over sine theta. So cosec of 2 theta, so cosec of 2 theta is going to be the same as 1 over sine 2 theta. Okay, so let's say we solve for x. X is here 1 over 2, or x will be negative 3 divided by 2, or x is going to be negative 3. That is if you let each one of those brackets equal to 0. Now, we are not looking for x now. We are looking for cosec of 2 theta. So cosec of 2 theta equals to a half, or cosec 2 theta equals to negative 3 over 2, or cosec 2 theta is equal to negative 3. Now, one of these will not work. Okay, if we have to know that cosec is the same as sine, is the reverse of sine of 2 theta, which implies that we have to reverse the fraction. So this is not going to work. But here you can have sine 2 theta. Yes, if you switch this, this becomes negative 2 over 3. So that works. And here the same sine 2 theta. And this is going to be reverse of that is negative 1 over 3. There we go. Now, what is our domain? They are saying that theta lies between 0 and 135 degrees. Let me just save and also take a snapshot of that. So this is okay. So that's what we know. So what is our new domain? Our new domain would be 2 theta now. So this is 2 theta, and 2 of this is 270 degrees, and 2 of that is just going to be 0 degrees. Okay. Now you also know that from your cast diagram, you should know that let's say that's 0 degrees. Let's say that's 90 degrees over there. 180 degrees, and let's say 270 degrees. We know that sine is negative in this quadrant, okay, because of our new domain give us that direction. So what we are going to do is we are going to calculate our reference angle, and we are going to add 180 plus something of that reference angle. I can call it K, because it's 180 plus that. Right. So let's use in the case where sine 2 theta is equal to negative 2/3. Let's take that part and make sure your calculator is set in degree mode. So if you take our reference angle, okay, which can be like the K, if we take that, then we take the inverse sine of the positive stuff, right? That is the key angle we are working for, because that is what we are supposed to add 182. So that's going to be the inverse sine of 2 upon 3. Okay, this calculator of mine is still in radian mode. So we're going to move it back to degrees, and what we are going to do is I'm going to change that back to degrees. I'm going to change that back to degrees, so because it was in radian mode. All right, so that's the answer in degrees. That's our reference angle. Okay, my calculator is now back there. So the solution is going to be 2 theta is going to equal to 180 plus 41.810314 degrees. And what we're going to do is we're going to take that answer and we are going to divide that answer by 2 to get theta. So we take our answer that we get there, we divide it by 2. All right, let's bring my calculator, add 180. Gives you that within our range. Can you see that 221? Our range was 270 divided by 2, our original domain. So it's also within our original domain, okay, because our original domain was between 0 and 135. So that's one condition. If we take the second condition, the sine 2 theta is equal to negative 1/3. So if we take this second one, if we say sine 2 theta equals to negative 1/3, and we have our reference angle, our K, is the inverse sine, positive one, all right? Remember that? That is what we're going to add 182 because it's also negative in that quadrant, so we must add. So we are going to take the inverse sine, arc sine of 1 over 3, and that gives us 19 point something, so that is the angle that we are going to add 182. And if we take that answer, so we're going to say that therefore 2 theta will be 180 plus 19.471 and so on. And theta will be this answer that we are getting, we're going to divide it by 2. Okay, so let's just grab our calculator, just add 180 to it, add 180 equals to 199, which is still within the range. Divide that by 2, we are still within the range there. Okay, so this is our answer. Then obviously this now implies that my two solutions, okay, my two solutions are going to be, for theta, is going to be this one over here and this one over here. So I'm just going to write it nicely, theta into 1 decimal place, okay, theta to 1 decimal place. So therefore theta is equal to 99.7. Okay, let's write that 7 nicely. And of course, here we go again. Let's hope it is restored. Otherwise, you know, this is one of those moments. It's very difficult. There it restores. When you're working under such conditions with such, you know, problematic things. Anyway, 99.7, that is going to be to 1 decimal place, and the other one is 110 point, let's see what it was, 110.9 over there, so 110.9 it is. All right, so this is our solution. Okay, our domain was between 0 and 135. It's within our domain, and that is the solution to that. Right, so this was in last year's paper, and that is how supposed to do it. Now, hopefully you can check the video. Right, some of these things have disappeared. I've done quite a number of explanations there, and so on. Right, I'll be doing the second video, which is very similar to this one.